folks, welcome out there. It is MATHLINE time, and I hope you've got the right place. If you don't, stay with us. I'm Ernie Roberts. I'm your host for this afternoon session of MATHLINE. Specialized segments kind of day. Get your pencil, get your paper, get all those good things ready. But you know what? Been a little different around here. Let's see what today's topic is going to be. Get ready. I'm ready. Are you ready? Is everybody ready? My crew is ready. We're all ready for the big reveal. Let's talk about what the big reveal is going on. We have been doing Facebook and other types of problems of the day. If you've been looking and watching for us there, they're there. But if you haven't been, we need to get you there Monday through Thursday. And that's what we're going to do today. That's the big reveal. We're going to show you the solutions. So if you've worked them out, awesome. If you haven't, we're going to give you a chance to work along with us. So get, again, pencil, paper, even a calculator maybe. I don't know about the calculator. But let's get ready and go, all right? How about our first problem of the day? Fraction action. Use one order of operations to simplify and reduce to one fraction in lowest terms. Now, one order of operation, we're going to have to do more than one order, I think. We're going to have to do what first? What do we got to do? Everybody's talking out there? Multiplication. All right, so be sure you do that. Then we'll come back and do the addition. That was what we want to make sure of. So let's take a look at this little problem and see how it works. Lots of good things going on here. We have, remember, that's a fancy X, isn't it? That's a multiplication sign, by the way. So let's just make it like a little normal X there. That's pretty good. Everybody got it? Yeah. So got a chance to write it down at home if you have already. And let's take a look at this thing. I've got 3 in the denominator. Whoa. Plus 1/2. That 2/3 plus 1/2. But we don't do that first, right? We mentioned that earlier. We've got to go to the multiplications first. So I'm going to just rewrite it down like the rest of y'all are doing. And let's do the multiplication. Now, there aren't parentheses there, but if you want to put some there to help you out, that's fine. That's fine. All right? So looking through there, keep the 2/3 where it is. We'll worry about it in a little bit. Let's worry about our multiplication. So we're taking half of 3/4. Well, if we divide fourths by 2, that means we're into eighths. So I'm thinking it's going to be some amount of eighths here. So let's take a look at what happens. Like I said, forget the 2/3 here. Let's just put a little bit of parenthesis action around there. I see no cancellations. I see nothing on the diagonal that's going to work its way out of the picture. So it looks to me like we are sticking with 3/8. So far, so good. Everybody see what I did? 1 times 3 gives me 3. 2 times 4 gave me the 8. We're good to go. Nothing able to reduce at this point. Now, some of you are going, oh, Ernie, you mentioned something about no cancellations. Can we cancel the 3 and the 3 now? No. That's a plus sign. So what we need to do is we need to get this 3 and this 8 to be the same number. Now, I'm looking at these. You're looking at these. If we multiply them together, absolutely, you're going to get 24. 24 is a number that 3 would divide into, and that 8 would divide into evenly. That's always a great way to go for a least common denominator. And since 3 won't divide into 9 evenly, I pretty much know I have to multiply those two numbers together to get where I'm going. So let's talk about it. We chose 24. I'm going to go a little more room here. 24 here, 24 here, and we're going to put a plus sign right in between there. Now, you say, Ernie, wait, what did you just do? What did I just do? I took 3 times 8, got the 24, pop, there it is. Now what I've got to do is adjust the numerator and adjust the other numerator. We've got to do both of them in both of these fractions. So let's remember, what do we do here? On this side, we multiplied by the 8. On this side, we multiplied by the 3. Not because there's a 3 up there, but because the 3 times 8 is what gave me 24. Okay, 3 and 8, 24, 8 times 3, 24. Etc., etc. Now, what change did I make over here? I did an 8, right? So I must do that to the numerator. It's like multiplying, look at 8 over 8. That's like multiplying by 1. That means we didn't change anything. We just made numerator and denominator into different numbers, but they still give us the same 2/3 back if we try to reduce. Speaking of which, 16 pops in right there. Life is good. Let's keep working it. Everybody still working out there? I'm glad you are. Now, let's do the same thing here. We multiply by 3. We get our 9, and I'm seeing 16 plus 9. I can do that in my head. I hope you can. We're going to get 25, everybody with me, 25, over a 24. Now, You can leave that as an improper fraction. I'll give you permission at this point. However, your teacher, especially if you're in the 5th, 6th, 7th, and 8th grade, is probably saying, I want a mixed number. And that's fine. That's fine. So out here to the side, we're going to say, let's divide 24 into 25. That's what this is. It's a division. Fractions are just simply divisions, my friends. All you got to do to figure out where they are or what they mean is just run a division on them. And in this case, how about it? What we got? It looks like we got going in there one time, multiply that, 24. We have 1 left over. So either way we look at it, you could go with this one. I would say, ding, ding, you're correct. That's cool. That works. On the other side of the coin, I would say, hey, let's go here for mixed numbers because I like to have mixed numbers. They make a little more sense to me. They really do. It means 1 and just a little bit more. Just a tad more. 1 over 24, 1/24 additional. It's a very small amount. So there you go. Either way, I hope you guys got it. There's your check. There you go. Problem of the day solved. By the way, if you want to send us a problem of the day or some things for us to work at here on the show this summer, send it to tnlearn.org, mathline@tnlearn.org. That's our email address. We mentioned Facebook. Let's look at it one more time. We've got Facebook. We like it when you love us. We like it when you like us. And we also really, really, really love when you share us with other folks at www.facebook.com/MathLine online. And that's where you can pick up our problem of the day every day, Monday through Thursday, as we work through. Now, what's going on? I think we've got another problem of the day, right, guys? And here it is. It's a computer problem. You know, don't have to have a computer to do this one, though, but it's just about a computer. A computer selling for $350 has a markup of 2/5 of its original price. Ooh, that sounds complicated. We're going to try to figure out what that original price is. So let's see where we're going to go. On this problem, first of all, you are dealing with a computer. They do cost money. And when people buy them and sell them, they usually sell them for more than what they paid for them, all right? What they bought, because that's how you make a profit. So let's see what's happening on this little guy. So we're going to start with a original price. We'll talk about it there. It's dollars, it's some amount. And we're going to add on a markup. And we're going to get what we're going to call our selling price. In other words, those three things work together. So if you take the original price, do we know what it is? No, we don't know what it is. So put it in right there. And how about the markup? Ooh, 2/5 of its what? Original price. We know the original price now. We're getting smart, aren't we? So we're looking at 2/5 of that end value. I'm going to go right there. Now, some of you like decimals. That would be 40. Not 40, but 0.40 or 4/10 or 40/100. So, you know, be sure you put, if you're going to change to a decimal, be sure you do it right. But 2/5, we can handle that. Oh, by the way, put a 1 in front of that end so we don't forget. Out here, oh, we know what we're going to sell. We got $350. The ingredients are set. It's algebra time. Easy algebra, if you'll let it be easy algebra. Wow. How about it? We take 1 and 2/5. Well, that sounds just like what we should do. 1 and 2/5 in. We'll just make a mixed number equaling to $350 out there. Now, my friends, hang on. Hang on for the ride here because we're going to work this thing out. I want us to keep the theme of fraction here. So we got 1 and 2/5. Let's make it improper. Let's make it an improper fraction. Everybody good on that? Improper fraction? Sounds good idea. So let's go. 7/5 in equaling 350. Nod with me. You with me? Everybody got it? I didn't do much magic. I said 1 times 5, add the 2, 7/5. Now, how do we get this to be taken care of? A couple of ways we can go here. A couple of thoughts. I am going to go just kind of extreme on us here. I'm going to say, let's use a reciprocal. Now, you could have multiplied through by the 5 and then come back and divide it by 7. And I'd be going like, big numbers. Let's try that reciprocal business. Now, stop. Stop just a second here. Let's think about it. If you do it to the left side, where else have you got to do it, my friends? You tell me. You do it to the right side. Multiplication property of equality. We're multiplying both sides by 5/7. Drop a 1 under there. Life is good. You know why life is good? Because 7 divides into 35 evenly. That's why I told you it was going to be a lot easier if we played the 5/7 game here rather than trying to multiply by 5 and then divide by 7. Whew, big numbers all the way around. So let's see where this goes. Divide that 7 to 35. We said to go 5 times. Bring a 0 along for the ride. Say goodbye to all of these guys. They just cancel out. That's why we chose 5/7. So we could get all sorts of cancellations, and all you're left with is your lovely n. Guess what we're trying to find out? The original price, which is n. That's our defining of the variable. Our markup, and we'll figure that out too. Everybody, we're going to check this thing out, make sure it works. We're not going to leave you hanging, right? It's MATHLINE. You know us. We're going to take good care of you. And let's kick along here. How about it? $250. That's what I get. 5 times 5, 25. Add a 0 to the end. 250, and we are talking dollars. Now my question is, 250 plus 2/5 of 250. Do you get $350? Do you get $350? You're going like, Ernie, I think we do. Ernie says, I know we do. So we got 250 right here. Let those 5 and the 250 disappear, do whatever they want to do. We got 50, right? Because 5 goes into 250, 50 times. 5 into 25, 5 times. Add a 0. 2 times 50. Can we do that in our head? Of course we can do that in our head. Double the 50. Think money. It is money, isn't it? So we're going to add $100 to that, and we're going to get 350. My friends, check-a-roozy. There it is. Works out beautifully. Double check because it worked great there. Works back here. Solution solved. There you go. Problem of the day. And again, remember, you can catch us on that great email address, and you can also send us these problems that we'd love to hear from you on mathline@tnlearn.org. Hey, another problem of the day coming our way, of course. Let's check out our next problem of the day. If a rectangle has an area of 40 square inches, we're going to inches instead of metric today. That's kind of nice occasionally to do that. What are the possible perimeter values if the dimensions are both integers? So it means no fractions involved, no 2.4s or 2/4 or things like that. All nice whole numbers. They'll be positive too because we're talking lengths and widths here that add up to make perimeters. By the way, everybody knows what perimeter is? Let's make sure we got that straight. Area is all this lovely blue inside here, inside the rectangle. More area over here. By the way, the idea both of these have the same area. They just look a little different dimension-wise, okay? Because there's more than one way to get 40 square inches out of something. Now, perimeter, what are we looking for? We're looking for all 4 sides added together. So this is going to take a little bit of work, a little bit of effort if you haven't already done it. And if you have done it, it's not so hard. But let's do this. Let's write length and width into a coordinate form here. Now, I'm thinking 40. What's a rectangle? Length times width. Everybody nod with me? You agree? We're going to break this thing down easy. All right, so we're looking at rectangle areas. We know we find it by the length and the width being what? Multiplied together. Wow. So let's think of some ways we can multiply to get what number? Big 40, 40 there. Yeah, some of y'all out there are adult population going, I remember the big 40 years. But anyway, that's another story. This is at 40 square inches in a rectangle. Now, let's take and see where we're going to go with this. I like 8 and 5. You know why I like 8 and 5? Because we had multiplication tables. They were easy. Well, we also had what? 4 and 10. And by the way, these are all little inches, so here we go. I like that. It gives us 40. Get the idea? So now let's think of some other values that could get us to 40. Well, we know for sure we could always use 1 and 40 as one option. By the way, remember we're going to find the perimeter in just a minute? What's another one? Oh, 40's even number. Toss in a 2. 2 and 20. So let's play the perimeter game. We'll come back and play the perimeter game off these since you got the pictures all sitting there looking at you here. How about it? Ooh, what is the formula for perimeter? We're going to add all four sides, right? So I could put 1 plus 40, 1 plus 40, or how about it this way? But we say 2 times 1 plus 2 times 40. Well, you say, well, Ernie, that looks pretty good, doesn't it? So we got two 40s, and we've got two. That's a real stretched out rectangle. Very, very slender, very slim. So what have we got there? It looks like 82. Now let's go 1 second moment here. We had square inches for area. We don't do that for perimeter, right? You got it. So just put inches. So we're all about inches here. All right, let's go continuing on. Let's continue on. How about it? How about the 2 times 2 plus 2, and that's a little x there, times 20. Now remember, we do the multiplications first, all right? Then we come back and add. So 2 times 2, everybody got that one? 4, keep that in your head. Plus 2 times 20, that's 4, I get 44. 44 inches. We sure did come up with that. Oh, wow, that's the same area, 40 square inches, but boy, we sure had bigger numbers here. Now we're getting smaller. How about these next two things we got up here? Let's go ahead. Let's see what happens when we put 4 and 10 in the mix. We're going to put 2 times 4 plus 2 times 10. And again, do that multiplication first. My dear Aunt Sally says so. Multiplication, division come before addition and subtraction. And we have 8 plus 20. I'm seeing 28 inches working out there. And how about it? One more kickoff here. 5 and 8. And we go 2 times what? 2 times 5, yeah. Because remember, there's 2 lengths or 2 widths, however you want to look at that one. Plus 2 times our 8. And again, we're going to come back and play that game. 2 times 5 gives us 10. And 2 times 8 gives us 16. Add that together. 10 plus 16. Mental math time. Yeah! Mental math time. I agree. 26 inches. And there are your 4 perimeters. And there are your 4 actual answers and solutions of the possible perimeter values. Each of these depend on how you stretch out that length and that width. So again, another problem, but they all have one thing in common. The area was 40. Now, let's go one more problem of the day. I think we've got time for it. Certainly we do. Let's see what we got here. Hey, do these prices for beverages follow a linear pattern? That means if I were to graph in some way, putting these as ordered pairs and graphing, would they line up in a straight line? A 3-pack for $1.80, a 4-pack for $2.40, and a 12-pack for $7.20. And we're going to try to explain our reasoning. All right, so everybody good on that? Got all those ideas? Write them down at home, wherever you may be right now, in the library or wherever you're studying. Let's check this thing out and see how it's going to work. First of all, I suggest let's make a little table, and then we're going to make some ordered pairs happen here. So the first thing is we're going to let X be the amount of beverages you're buying as a collection. A 3-pack, I don't know if I've seen many 3-packs, but you know, there's sometimes triple things in that. So we're going to say maybe you got 3 cans or 3 bottles or whatever. But you paid for that 3, you paid $1.80. There we go. Make that sure that looks like an 80. For a 4-pack, definitely see those happening with bottles more so than cans, but you will see $2.40. That's the game plan on that. So we're going to just make a table here. Keep going. Let's go for a 12-pack. Big amount there. And we'll put that in. By the way, it's a dozen, isn't it? So $7.20. Starting to see my idea. As ordered pairs, that would give us 3, $1.80. Would give us 4, $2.40. How about it? 12. There we are. Now, what we'd like to do is figure out, is the slope, is the rate of change the same throughout these 3 situations? In other words, do we save money by buying in bulk? In other words, we're going to get a better deal by paying less per item maybe? That's what we're looking at. Basically, what is our unit price is what we're going to compare all this with. Get the same unit price, it's linear, and hey, you can buy 1, 2, 3, how many? You're going to get the same deal, right? So let's see how this works out. First of all, let's just start with the simple ones right here. Let's use these 2 points right here. We're going to look for the slope. We'll call it slope 1. Rate of change. Everybody good on that? What is the rate of change? It's the difference in y's. And I'm going to use the y2 minus y1. Some teachers use y1 minus y2. It doesn't really matter. And make sure, though, once you pick your y2 and your y1, you keep your x2, which is your second x, and your first x lined up accordingly. So in other words, for our first little slope out here, we should have, looks like, about to run out of my room, I believe. Let's put it down here below it. How about we're going to go with $2.40 minus the $1.80. All that good stuff over. Looks easy. 4 minus 3. So it looks to me like we did 60 cents based on, obviously, 4 minus 3 is 1. So we're going to go with that being our rate of increase, rate of change here, if you will. Looks to me like, at least in this case, you're paying 60 cents a can or 60 cents a bottle, whichever way you're going. Now, let's play it with the second possibility. Slope 2. Let's use these two guys right here. Let's use our 4. Let's go ahead and use the same formula again. We're going to put it right back in there, y2 minus y1. Kicking that over. And we're going to change it this time to, well, we're not going to change the formula. No, we'll come back to that in just a second. We'll put the numbers in differently. But there we go. Formula stays the same. Everybody good on that? Let's put it out here and let's do subtraction. How about it? $7.20 minus the $2.40. Those are your y values. Remember, that's the deal. Underneath, a little bit different this time. We got 12, it looks like, minus 4. So on our calculators and such, well, I'm going to do that with us here to save us a little time. Let's go ahead and see what $7.20 minus $2.40 gives us. It looks like $4.80. So here we go, $4.80. And what's going on underneath here? Coming back to our page of paper here. If we check and see, there we go. 12 minus 4. 12 minus 4 is going to give us our 8. And that will give us, again, oh my goodness, 60 cents. Now, what's going on here? We have the same rate of increase going from 3 to 4. We also picked it up with the same going here, 4 to 12. So you're saying, well, Ernie, if we had picked the other two options, which could be using 3 and 12 and $1.80 and $7.20, we could do a quick mental check on that. Well, let's see what happens when we take $7.20. We'll just do it on the calculator. How about it? Let's go $7.20. And this time we're going to subtract the 240. Oh, we did that already. We're going to go back to 180. Sorry about that. 180. Let's see what we get. Well, we get $5.40, it looks like. But this time, we're going to subtract 12 minus 3, which gives us 9. So we're going to take this amount right here, and we're going to divide it by 9. We're going to see, do we get 60 cents again? I jumped the gun. I was excited. I knew what we were going to get. Let's try it again. $5.40. I love it when I hit a wrong button. Not really. Let's go by 9 this time. That's what we're looking for. We're looking for that definitely elusive 60 cents, and there it is. Folks, you got it right there, 60 cents. So the rate of change is, again, 60 cents. So we've got this 60 cents, 60 cents, and 60 cents. In other words, if we took these two together, we take these two together, or we take these 2 points together, we get the same rate of change, which is, you got it, 60 cents. So, Ernie, everybody watching, what does that tell us? It tells us a relationship between y and x here. Y is always equal to, or if you like the money, 60 cents times x. X is the number of bottles or number of cans. Y, that would be your total cost. And there we'll call that your number of whatever. Containers, how about that? Containers, everybody says, I like containers. I do too. There you go. So what did we get from this? If we have a linear pattern between a set of points, it could have been 4 or 5 here. we can come up with that constant rate of change. Do we have to go through the slope formula? No. You can simply do some subtracting, which is what you're doing. When you said 240 minus 180 here, divided by 4 minus 3. That's exactly what you're doing. You can use your table and work that through. Same thing here. Remember what we ended up? We ended up with 8 here. We ended up with 480 here, and then so forth and so on. So, yes, the answer is big old yes, because the rates of change, which is the slope, stays constant for all those points. Hey, thank you for tuning in today. By the way, remember, we are going to be able to take your questions at mathline@tnlearn.org. Take care of us on that. And you know what? As always, we tell you, but it's true, we're going to see you once again next time.